Today we're going to move into the programming section of our class. The rest of the class will compose our discussion of algorithms and flowcharts and programming concepts and all of the ins and outs of writing code. So we're going to get started today talking about algorithms and flowcharts. We talk about an algorithm in the context of a recipe, if you will, or a set of steps that can define a problem and identify a particular solution to that problem. In general, when we talk about writing code or a program, we're generally talking about breaking it into two different phases. Number one would be the problem-solving phase, and that is the part where we actually figure out what the sequence of steps are that would describe a solution to that problem. And we're done with that. That is basically called an algorithm. And then the last part is the implementation phase, and that's where you really write the code. So keep in mind there's a couple of different parts. Anytime you're dealing with writing a program, you have to first define what it is that you're trying to solve and what the steps are to make that happen. And then the last thing you do is actually go and write the code. So let's take a look at the actual steps that are involved in the problem-solving aspect of this. So the first thing we want to do is create a general purpose kind of an algorithm. And there's something we can use to do that that's called pseudocode. It's not real code. In other words, it's not statements in Python. It's more along the line of an English language type of a solution. Makes it easy to do because we can just talk about it in our normal language. So once we've got that written down, then we can begin to take that and refine it into the actual program statements that the computer needs to have in order to function. So pseudocode's an algorithm. Let's take an example. The best way to learn this is through a bunch of examples. A lot of the remainder of the course is going to be examining examples of code that other programmers have written and then taking that concept and applying it to a particular problem that we have to solve. So let's look at an algorithm that would be used to calculate a student's final grade and indicate whether it was a pass or a fail. And the method used to do that for this particular example is that the grade is calculated as an average of 4 marks. So here we have the pseudocode. As you can see, it's pretty much an English language kind of a thing, as if we were describing it to each other. We're going to input a set of 4 different marks. We're then going to calculate their average by summing them up and dividing the answer by 4. If the average is less than 50, we're going to print fail. Otherwise, we're going to print pass. Pretty simple. So let's detail that out just a little bit. We'll get a little bit closer to actual coding and writing things in programming statements, but this still isn't code. This is just a little bit more detailed, more code-like, if you will. So now we're going to say that step 1 is to input mark 1, mark 2, mark 3, and mark 4. Then working over here from the right, we're going to say, well, we're going to sum up mark 1 through mark 4, and then we're going to divide that by 4. That will give us the average. And we're going to assign the results of this calculation into a variable, and we're going to call that variable grade. Step 3 says that if the value currently held in the variable of grade is less than 50, then we're going to print fail. Otherwise, we're going to print pass. And that's the end. Now, this scenario that happens here is common logic. We could, if we were trying to be extraordinarily explicit, say, if the grade was less than 50, print fail. If the grade was greater than 50, print pass. But we can use basic logic in the context of true and false. If something isn't true, it has to be false, and use that to our advantage and only evaluate a single statement and make a decision from that statement. And we'll get into more of that as we look at some of the decision statements. Another way that we often represent a decision-making process, or perhaps I should say a flow of decision-making processes and programming sequences, through the use of something called a flowchart. Now, you may have seen flowcharts in the past, and there are certainly many different kinds of flowcharts that you can create. Each style of flowchart typically may have a whole set of symbols that is used to define that aspect of not necessarily programming, but whatever the arena is that you're working the flowchart. And even something as simple as an organizational chart from a company is in some respects a flowchart. It talks about the flow of responsibility, more or less, within the organization. So a flowchart, a graphical representation of a sequence of operations, and they show how the data or the thought process, the logic, if you will, flows through the problem definition and through the statements that solve the problem until it finally comes out the end in some kind of a result. So it'll show the sequence of instructions. That's the main thing. That's the big takeaway. It'll show the sequence of instructions, and that there are different symbols that are used for each type of flowchart. So, okay, here again shows the logic of the algorithm, shows the individual steps and their interconnections, and lastly, it shows the control of flow from one action to the next, hence the word flowchart. These are the symbols that we typically use when writing programming flowcharts. We'll generally have a oval symbol that denotes the start and the end of the program. There will be these parallelograms that denote inputs that come into the program. The rectangles denote some kind of a process that's carried out. The diamonds are used to indicate decisions or branches, the if, then, else type statements. Then we have output, typically designated like this, and the lines with arrows that connect them. So let's take a look at an example. Here's it's the same problem about calculating the average and generating a print and fail, or printing a fail or a pass based on the result. So here's the oval that designates our start. I have another one down here that designates the bottom, the stop. The first thing we do on this program is we gather some input. Remember, we input the 4 different marks. So we'll just simplify that into one statement here. Input the 4 marks, and then we pass control to the next statement. This is where we do our calculation. This is the rectangle, so there's actual process going on here. Then we go to the next step. We pass control down to the decision statement of is the grade less than 50. That's a logical decision statement that's evaluated, the result being either true or false. If the result is true, we'll follow the yes path down and print fail. Otherwise, we would follow it this direction and come down and print pass, and then finally we stop. So that's a simple example of a flowchart. All right, let's look at another algorithm real quick. Draw a flowchart, and this particular little program does nothing more than convert the length in feet to that in centimeters. So it's a conversion program. Pseudocode for this would be input from the user the length in feet, do the conversion, change it into centimeters, and then the output. Send the output out, print the length in centimeters. So let's take a look. This is a little bit more detailed algorithm input, and we're actually, giving it a variable at this point, calling it a name. Input this value, do our conversion, and assign the results to this variable, and then print the value that's held in that variable. And here's the flowchart. Again, our start and stop. We have our input, we have our process, and we have our output. Again, it's very simple. Here's another example. Take two sides of a rectangle and calculate the area. Again, a simple mathematical function, if you will, would be a typical word we would use in programming. This is a function. It takes a couple of inputs and provides some outputs. So input, we have to know the width and the length of the rectangle in order to calculate the area. So those are our input variables. This is the statement where we actually do the math. We calculate the area. And finally, we print the results of the calculation, which was A. We print that out. Here's again the more detailed algorithm. Input these two variables, take the values in there and multiply them together and assign the results to the variable A. Finally, print out the variable A. And again, you can see the example of the flowchart, very basic stuff. So let's talk a little bit more about the actual decision structures. These are something that are very important in controlling the flow of your program. You have to be able to understand how these things are put together and how to evaluate the results, because you can twist the logic around to meet your needs. So let's look at here. The expression A is greater than B is some kind of it's a logical expression. It's either true or it's false. There isn't any maybes in here. So it describes the condition that we want to test. If A greater than B is true, then we want to take a certain action. And if the value is false, we want to take a different action. And either way, regardless of which action we take, we want to print the value of that. So this is what it looks like, graphically from a formula, like we saw before. Have the diamond, which is the decision statement. So as control is passed into this calculation or this decision statement, is A greater than B? Two choices to leave this structure, either yes, which we print A, or no, in which we print B. Can only be two choices, A or B. So these are decision structures, and you'll start to get the hang of these as we move forward in our coding. This is a general purpose breakdown of what the if, then, else structure looks like. We have the if condition. The condition generally might be in parentheses. And we have the statement then. So if this evaluates as true, we drop down and we execute what's indented underneath of this statement. Else means that this condition was false. So the else would relate to false here. So we would do the false alternative. And then finally, we would terminate the if statement with an end if, which would close this out. So you need to pay attention to these things and make sure that these things match up, the if and the end if statements. Otherwise, you can get into some interesting nesting going on. So here's our algorithm again. If A greater than B, then print A, else print B, and then end if. And there's the representation graphically. So as we're working with these logical operations, the relational operators that you're going to use are typically going to be greater than, less than. A lot of times it will be equal to, because you're looking to match a certain value, or whether it's numeric or the value of some particular character string. Sometimes, with math, you can obviously be looking at greater than or equal to. Those kind of things can also be used for character evaluations as well. And not equal to is sometimes used if it fits the logic of the flow. And you'll see some examples of that later. Now these particular operators are what you're used to seeing, and may not necessarily be what's always used within the programming syntax or the language. It depends a little bit on the language, how some of these are this actual true syntax. We're just speaking kind of in generics at this moment. So here's the last example. Write an algorithm that reads a couple of values and determines which one is the largest, and then prints that value with some kind of an identifying message. So we'll just kind of skip the real generic pseudocode, jump straight into the more detailed style. We'll say we're going to input value 1, comma value 2. If, note that the expression we're evaluating is held inside the parentheses. If value 1 is greater than value 2, then assign the value 1 to the variable max. Otherwise, assign the value 2 to the variable max. Finish up our end if, or our if statement, and then lastly, print the text. The largest value is comma and whatever is in max. So what's printed here is either going to be this or this, depending on how this expression was evaluated. And then here's an example of the flowchart that represents that little algorithm. Again, the start and the end are in the ovals. We have input of our two values. We have a decision statement, which can only be true or false. Depending on that, we assign the proper value into the variable max. And finally, we do our output, which is printing the text the largest value is. Note the quotes around the text, comma, and then max. All right, so let's think about what happens if we need to make multiple decisions. Then we get into a condition that we call nesting. In other words, we embed an if statement inside of another if statement, and we call that nesting. So take a look at this example. If some condition, then, so if this is true, then do this. Well, it's another condition. So we're going to evaluate if something else, then do something here. Otherwise, do something else. I know that might look a little confusing, but just think, here's an if, and here's an else. Here's an if, here's an else. So this if and this else go together, and this if and this else go together. It's really not too bad as long as you pay attention to the indentation in your code. You can generally keep this stuff straight, and also the editors that we'll be using are generally pretty good at helping you keep track of them. They provide some visual clues about which else matches up to the previous if. So we're going to expand our little algorithm and now look at 3 different numbers and figure out the value of the largest number. So we're going to up the complexity of this just a little bit now. So we're at step 1. This is our detailed algorithm. We're going to do an input statement again. This time we're bringing in 3 different numbers, N1, N2, and N3. Now we're going to go and set up our first conditional evaluation. We're going to take a look at the first 2 numbers, N1 and N2. If N1 is greater than N2, then we've determined what? Well, we've determined that N1 is larger than N2, so we've eliminated N2 as a possible candidate for being the largest number. So at that point, we're only interested in comparing N1 and N3. So we can jump right into the next evaluation statement and say, if N1 is greater than N3, then at that point we now know that N1 has to be the largest number, and so we assign that value into max. Now by the basis of elimination, if N1 was larger than N2, but it's not larger than N3, then we know that N3 has to be the largest number, because obviously N3 is larger than N2. So we can immediately jump to this conclusion that N3 is the largest number and assign that result into the variable max, and then close out our end if statement, or our if statement here. So if this has all been evaluated, because this statement was true, the else never gets evaluated. It will never evaluate the else if this is true up here. We'll only jump to this statement when this is false. So had this all been true, we'd skip this, we'd drop down here, we'd end the if, and we would print the largest number is, boom, in this case it would be in 3, or either in 1 or in 3. Okay, wow, so this stuff can obviously get a little difficult sometimes to track, but that's part of what coding and programming is all about, is being able to follow the logic of the sequence of steps of instructions and what's going on here. So I won't take the time to go through this. I think you can evaluate that aspect of it on your own. So how do we draw a flowchart of something like that, where we have multiple, or a nested if statement? Well, not with that slide. Okay. All right, I think that might have been a homework assignment. Perhaps that's what the homework assignment is, and we'll go check that out.